The RPM40R is a self-contained, mechanically driven, attachable, two-stage snowblower manufactured by RPMTech in Quebec, Canada. Self-contained, meaning it has its own internal power source, in this case, a 375 horsepower diesel engine. Mechanically driven, meaning the implements receive power mechanically as opposed to hydraulically. Attachable, meaning the blower head can be mounted and swapped between various front-end loaders. And two-stage, meaning that snow is processed in two stages. The first being the front auger collecting the snow, and the second being the impeller ejecting the snow. The 40 refers to the diameter of the front ribbon, which in this case is 40 inches. Some other important measurements include the width at 116 inches or 9 foot 8, as well as the height at 140 inches or 11 foot 8 when the chute is fully lowered. Finally, the entire machine weighs 12,000 pounds while carrying 100 gallons of diesel fuel. All of this combined means that the RPM40R is a very large and powerful machine. As the operator, it is your responsibility to take this into consideration so that you may operate this machine in a safe and effective manner. Before inspecting the RPM40R, we must first discuss some safety concerns related to this machine's remote start capabilities. Primarily, we need to discuss the importance of two switches, the battery disconnect as well as the radio remote control disconnect. Both of these switches are extremely important, and both can be found at the rear of the machine. For the safety of yourself and others, it's crucial that both of these switches are turned off and deactivated during your walk-around inspection. Unlike other machines that use a hardwire connection, the RPM40R instead uses a wireless signal to a remote controller mounted in the cab. And although a wireless connection does provide benefits, it also presents some additional safety concerns. Most importantly, you must understand that if the battery switch and radio remote control switch are on and activated, then this machine can be started at any time, from anywhere, and without warning. This will be true even when the blower is not physically attached to a front-end loader. Furthermore, each specific blower head is paired to its own individual remote controller. These pairings are exclusive and cannot be changed by the operator. Therefore, it's vital that the paired controller remain with its corresponding blower, even if the blower is moved, detached, or swapped onto a different loader. Failure to keep the paired units together may lead to a potentially dangerous situation, which I'll explain. It's the beginning of shift. You and a coworker have both been assigned a loader with an attached blower. For whatever reason, the two loaders have swapped blower heads, but they did not swap the remote controllers inside the cabs. You and your coworker begin your pre-trip inspections, but your coworker has a bad habit of activating his battery switch and radio remote control switch during his walk-around while he is still inspecting the machine. After finishing your inspection, you climb into the cab. While preparing the cab, you forget to check that you have the matching controller. When you try to start your blower head, you will instead start your coworker's, putting him in a very dangerous situation. And although this situation may seem unlikely, we must remember that people can get complacent, and as a result, mistakes can happen. Ultimately, both parties made mistakes that contributed, but fortunately, there are multiple ways to prevent it. First, you must never activate either switch until you have finished your inspection, are in a safe position, and are completely ready to start the machine. Second, when you enter the cab, you must always verify that you have the correct corresponding controller before attempting to start the blower. If you can incorporate both of these steps into your pre-trip routine, you will be able to protect yourself as well as your coworkers. So with that in mind, the first step at the beginning of every shift should be to ensure that both the battery switch and radio remote control switch are off and deactivated. Once that's done, we can begin our walk around. With both switches deactivated, we can now begin our pre-trip inspection, starting with the main engine compartment located at the right rear corner of the machine. Before opening the engine compartment, let's first take a closer look at the right side, specifically in the RPM40R cutout. Looking closely, there are two sight glasses for the engine coolant level. Please ensure that coolant is visible within both sight glasses. Stepping back, the engine compartment is secured by two rubber latches, one on each side. With both latches undone, use the center cutout along with the grab handle to pull, tilting the engine compartment open. With the hood open, start by inspecting the engine from the rear side, looking for leaks or anything unusual or out of place. While inspecting the rear engine compartment, you'll notice an engine oil dipstick tucked back behind the engine oil filter. This is the first of two dipsticks that can be used to check the engine oil level. However, there is a second oil dipstick in an easier to reach location that we'll touch on in a moment. Shifting to the right, this engine is equipped with a reversible engine fan, and above it is the engine coolant reservoir and fill point. Once everything on the rear of the engine checks out, we can move around to the front. There is a small platform you can stand on to inspect the front of the engine. This platform also houses the engine's batteries. Looking into the front of the engine compartment, you'll notice two large fuel filters. To the left of these filters is the engine oil fill point, and to the right is the second engine oil dipstick. Although either dipstick can be used to check the engine oil level, you'll find that this one is a bit easier to access. Look over the rest of the engine, ensuring there is nothing out of place and no leaks. Once satisfied with the engine compartment, close the hood and secure it with both rubber latches. Moving forward, in front of the engine compartment is the drum, sometimes called the tub. The drum is a rotatable housing that controls which direction snow will be ejected. When the drum is vertical, snow will be ejected upwards into the loading chute where it can be accurately controlled. When the drum is horizontal, snow will be ejected to either side, providing greater distance but with little control. Around the circumference of the drum is the drum rotation chain. Following it downward, the rotation chain connects to a small hydraulic motor next to the front engine step. This motor is what moves the chain, causing the drum to rotate. Inspect for leaks and exercise caution when using tools to remove snow from this area. Do your best to prevent ice buildup along the chain, especially near the drum rotation motor. Please ensure the drum chain is adequately lubricated, while also noting the chain's tension. In addition to chain lubrication, the drum itself will have multiple grease points around its circumference. Stepping back, there is a large plastic sheet mounted on the front of the engine compartment. When the drum is rotated to the right, the plastic acts as a wear shield, protecting the engine compartment from abrasion. Inspect and monitor the engine shield so that it can be replaced when necessary. Above the drum is the loading chute. The loading chute is what allows the operator to control snow placement. At the bottom of the chute are two hydraulic lift cylinders used for telescoping the chute, one on the left and one on the right. The telescope function allows the chute to be extended upwards, providing additional height when loading trucks. Be aware that telescoping the chute may make the machine too tall to safely travel under certain bridges or overhead wires. Above the right lift cylinder is the machine's level indicator. The level indicator will tilt as the machine is pitched forward or back, giving the operator a visual gauge to determine when the blower head is sitting evenly. Above the level indicator, you'll see a large gear with several teeth. This is the chute rotation ring. The teeth on the rotation ring are fed through a small gear on the back of the chute that is then connected to a hydraulic motor, allowing the chute to rotate. The chute rotation ring will have multiple grease points. Above the rotation ring is the upper chute. The upper chute has a deflector that can be pitched forward or back. The deflector is connected to a hydraulic cylinder on the back of the chute. Additionally, the chute deflector has multiple grease points on each side. Lastly, there is a set of work lights mounted at the very end of the chute. When inspecting the chute, keep an eye out for leaks around the various hydraulic components. Back on the ground, the next area is the auger housing. The auger housing is the large cavity ahead of the drum. On the back of the auger housing is the manufacturer's nameplate, as well as some wiring for another set of work lights mounted atop the housing. Due to the electrical wiring, please use caution when using tools to remove snow from this area. At the corners of the auger housing are two large cutting vanes. The cutting vanes help funnel snow into the auger housing, but despite their name, the cutting vanes are very susceptible to damage, and therefore should not be used to cut through ice or extreme pack. Inspect the cutting vanes for bends, twists, or cracks, while also ensuring that all of the fasteners are secure. Hanging from the top of the housing is a rubber skirt. The skirt helps to prevent ice or rocks from being kicked forward. Ensure that the skirt is in place and secure. Within the housing is the auger. The auger spans the entire housing, where it is secured on each end. As the auger rotates, a grooved ribbon will chew up the snow, breaking it down into smaller pieces. Inspect the auger for cracks, bends, or other damage. The auger is supported by two bearings, one on each end. Ensure that both auger bearings are secure and receiving grease. Next to the left auger bearing is the breakaway plate. The breakaway plate connects to the auger shaft with two shear bolts. The shear bolts are designed to break should the auger strike a hard, foreign object. If the shear bolts are broken, the auger will no longer be connected to the drive system. Behind the auger is the impeller, sometimes called the fan. As the impeller spins, snow will be forcefully ejected from the drum. Around the impeller are paddles called flights, each with its own flight plate. The flight plates are wear items that should be inspected and monitored. Ensure that all of the fasteners are in place, especially the impeller's center bolt. Around the impeller is a thin liner that separates it from the drum. Inspect the drum liner along with its fasteners, ensuring a snug fit. From the inside of the auger housing, let's move down to see what's below it. Across the bottom of the auger housing is the cutting edge. The cutting edge protects the bottom of the housing while also scraping the ground to minimize any leftover snow. The cutting edges should be closely monitored so that they can be flipped or replaced when necessary. Beneath the corners of the auger housing are the skid shoes. The skid shoes provide additional wear surfaces, protecting the bottom of the machine as it slides across the ground. There is one set of skid shoes at the front, by the auger, and another set at the back, below the engine. Additionally, there are many more below the middle of the machine. However, many of them cannot be seen when grounded. Monitor the skid shoes so that they may be replaced when necessary. Lastly, there is one final wear item known as the curb plate. Located at the front right corner, the curb plate serves as a buffer when rubbing against curbs and sidewalks. The cutting edges, skid shoes, and curb plate are all wear items that will eventually need to be replaced. Along with each wear item, you should also inspect all of the fasteners securing them. Next, we'll be moving to the left side of the machine in order to review the mechanical drive system. Starting at the rear, the first part of the system is the clutch. The clutch is what engages or disengages the engine from the rest of the drive system. When the clutch is engaged, power from the engine will be transferred. When the clutch is disengaged, the power will be cut. The clutch is controlled with the clutch lever found to the side. The clutch lever can be moved hydraulically from the cab or manually from the ground. Moving the lever inward towards the engine will engage the clutch, while moving the lever out, away from the engine, will disengage the clutch. Before using the clutch lever, ensure the engine is either at an idle or turned off. Never move the clutch lever if the engine is running above idle. Opposite the clutch lever is the clutch position sensor. Please use caution when using tools to remove snow from around the clutch position sensor. Next, the clutch connects to a drive shaft, then to a planetary gear, before the chain cases, and eventually will reach the auger. But in order to also power the impeller, the chain case must also connect to a second drive shaft, which leads to a gearbox, and then the impeller. Additionally, the second drive shaft contains a set of shear bolts for the impeller, accessible beneath this cover. Similar to before, the shear bolts are designed to break should the impeller strike a hard, foreign object. If the shear bolts are broken, the impeller will no longer be connected to the drive system. Overall, the mechanical drive system is fairly straightforward, making it relatively easy to understand and diagnose. However, there are some major differences between this blower and some others that should be clarified. First, the drive system cannot be reversed. The auger and impeller can only be run in the forward direction. Second, neither the auger nor the impeller can be run independently on their own. On this machine, everything runs in unison. Third, due to the mechanical nature of the drive system, there are several additional grease points. The clutch will have 3 grease points, one by the lever, one by the sensor, and one in the center below the safety cover. In addition, each drive shaft will add several more grease points. Overall, it may be difficult to remember all of the grease points found throughout this machine. Thankfully, there is a posted maintenance guide above the drive system. In addition to the maintenance guide, this is also the breaker box, housing many of the machine's electronic switches. Next to it is the air filter, and below that is the hydraulic oil reservoir, complete with fill point and sight glass. Ensure that the hydraulic oil level is visible within the sight glass. Further down is the diesel fill point, and below that is the diesel exhaust fluid fill point. Unfortunately, you cannot check the level of either tank during your walk around. Therefore, you should plan on filling both before heading out. On the very back of the machine is the coupler bracket. This is where the loader's hydraulic quick coupler physically attaches to the blower head. When inspecting the coupler bracket, ensure that it is not cracked or bent and that all of the bolts are firmly in place. Within the coupler bracket are 2 cutouts. The left cutout provides access to the fuel tank, while the right cutout provides access to the hydraulic manifold. Use these cutouts to inspect both systems for leaks. Finally, above the coupler bracket are the aforementioned battery disconnect and radio remote control disconnect. If you are completely satisfied with your walkaround and you are ready to begin the startup process, only then should you activate these switches. Before starting the blower head, we'll first need to verify that our front end loader is in proper working condition and that the quick coupler is securely attached to the blower's coupler bracket. Assuming that both criteria are met, we'll climb in to review the blower controls. When entering the cab, the first step should always be to verify that you have the matching controls for your specific blower. In this case, the controller has a label on the bottom side, showing us a serial number. The serial number must match the one found on the attached blower head. The blower controls are mounted in the corner of the cab and consist of an ignition switch, an emergency stop button, a joystick, as well as a display panel. For the blower controls to function, they need to receive power from the loader, meaning the loader ignition must be turned on. With the loader turned on, we can then activate the blower controls by turning the blower key to the on position. This will activate the display panel as it goes through a short startup sequence. When the sequence finishes, you'll be left with the main screen. The main screen shows us engine RPM, engine hours, fuel level, def level, and engine load. The bottom portion of the main screen contains several symbols that we'll discuss in a moment. Additionally, there are 3 sets of LED lights along the sides of the display. Under normal conditions, only the green lights will be illuminated. Start the blower engine by turning the blower key past the on position. With the engine running, let's talk about the symbols along the bottom of the main screen. These symbols correspond with the 4 buttons found below the display. Pressing the button below the wrench icon will change the display screen, revealing some additional gauges. These gauges show coolant temperature, battery voltage, and engine oil pressure. Pressing the first button again will take us back to the main screen. Moving over, pressing the third button below the headlight symbol will bring up the light menu. Within the light menu, we have several options. Pressing the first button will toggle the chute lights on or off. Pressing the fourth button will toggle the headlights on or off. Pressing the second button will disable both sets of lights. When only the headlights are active, the main screen will show the headlight symbol with an additional box around it. When only the chute lights are active, the main screen will show the chute light symbol with an additional box around it. And when both sets of lights are active, the main screen will alternate symbols, both with the additional box around them. In order to activate both sets of lights, you'll need to go through the light menu twice, as you activate each set individually. Back on the main screen, the final symbol represents the clutch. Pressing the fourth button below the clutch icon will bring up the clutch menu. The clutch menu is how we engage the blower's implements. Within the clutch menu, pressing the third button will engage the clutch, starting both the auger and the impeller. Pressing the second button will disengage the clutch, cutting power to both implements. When the clutch is engaged, the main screen will show the clutch symbol with an additional box around it. Should you toggle the clutch while running above idle, the engine speed will automatically lower before toggling the clutch. Next, there are two hidden functions that we can access from the display. By holding down the second button for a few seconds, a new symbol will appear. This symbol depicts a locked out drum. When the drum lock symbol is active, the drum will no longer be able to rotate. To reactivate the drum rotation function, simply hold down the second button again until the drum lock icon disappears. The next hidden function occurs when holding down both the first and second button simultaneously. Holding both buttons will reveal a dialog box regarding the reversible engine fan. If we continue to hold both buttons, the engine fan will reverse as it enters cleaning mode. Cleaning mode is useful for when the radiator has built up material, and it will continue for up to 30 seconds or until both buttons are released. Once released, the engine fan will revert back to normal. Finally, it's important to note that the main screen may also display additional symbols such as low fuel, regen status, stop engine, and many others. These symbols can pop up in any of the various boxes. Therefore, it's important that we pay close attention to the display screen, as these warnings can appear unexpectedly. If at any time we need to perform an emergency stop, we can press the red emergency stop button. When the emergency stop button is depressed, an exclamation point will appear in the bottom of the screen, as well as a message along the top. The blower cannot be restarted until the emergency stop button has been released. To release the emergency stop button, simply twist until it pops up. The final piece of the blower controls is the joystick, which can be moved in 4 directions. Tilting the joystick forward or back will angle the deflector on top of the chute. Tilting the joystick to the left or right will rotate the chute. Additionally, the joystick has 4 buttons that can be used to further increase its functionality. On the front of the joystick is an upper index finger button, as well as a lower middle finger button. When holding the upper button, the joystick can be tilted forward or back in order to raise or lower the chute. Generally, the chute should be lowered while traveling and raised while actively loading trucks. When holding the lower button, the joystick can be tilted left or right in order to rotate the drum. This can be useful during blowback or when stacking, but keep in mind that this function can be disabled with the drum lock icon on the display screen. Finally, the two thumb buttons at the top of the joystick are used to control engine speed. The right button will increase engine speed, while the left button will decrease it. Ultimately, the manufacturer strongly recommends that this blower be run at a full 2200 RPM. Additionally, this machine uses a Tier 4 diesel engine, which will eventually need to regen. Regens are performed automatically and cannot be manually started or stopped. When a regen is active, a regen symbol will display on the main screen, and the machine will not idle down until it is finished. Lastly, there is one final detail that will help us when running this machine. Referring back to the main display, we mentioned 3 sets of LED lights: green, yellow, and red. The lights will change depending on the situation, providing a visual indicator for the operator, alerting them to high workload situations and possible shutdowns. Green represents normal conditions, but more specifically, an engine load below 100% and an engine RPM above 1800. Yellow warns of harsh conditions as the engine load exceeds 100%, while also causing the engine to drop below 1800 RPM. Pushing into yellow can be okay temporarily, but should not be sustained for prolonged periods of time. And red warns of extreme conditions as the engine speed drops even further, below 1600 RPM, while still exceeding maximum load. Running the machine in red greatly increases the risk of clogging the machine or shutting it down. In order to balance efficiency and machine longevity, it's recommended that we operate in the high green load range. At some point, we'll be required to perform some light field maintenance. In most cases, this will involve clearing a clogged chute or replacing a set of shear bolts. When maintenance is required, lower the engine speed to an idle, disengage the clutch, and back the loader away from the snow pile. Set the machine on the ground, then turn off the ignition to shut down the blower engine. If the blower has been working exceptionally hard, the engine may run for several more minutes in order to cool, delaying shutdown. Once the engine is shut down, the emergency stop button can be used to lock out the ignition switch, providing some additional security. However, we must not use the emergency stop button to circumvent a delayed engine shutdown. With the blower shut down, set the parking brake for the loader and step out. Next, disable the remote control switch on the back of the blower. The battery disconnect is optional, but keep in mind that we cannot turn it off while the red warning light is illuminated. With the machine grounded, the parking brake set, the engine off, and the ignition locked out, it is now safe to perform our maintenance. When replacing shear bolts, we'll want to remove enough material so that the implements can be spun by hand, while also searching for any foreign objects that may be responsible for the breakdown. With the implements free, we can realign the holes and replace the shear bolts. The shear bolts for the auger are located in the left side of the auger housing, near the left auger bearing. The shear bolts for the impeller are located in the second drive shaft, beneath this cover. Both sets require 2 5/16 grade 8 shear bolts, as well as 2 nylon locking nuts. As for tools, we'll need at least 2 1/2-inch wrenches, as well as a punch, a hammer, and a shovel. These tools should be on board every time we operate this machine, along with multiple sets of shear bolts. When addressing plugs, it's important that all plugs be dug out by hand. This may require restarting the blower in order to move the drum or chute into a more desirable position. However, under no circumstances is it ever acceptable to shake the blower head or tap it on the ground, as this will cause irreparable damage to the blower chassis. After completing the maintenance, turn everything back on and resume normal operation. When finishing up with the machine, ensure that the chute has been lowered, the engine is at an idle, and the clutch has been disengaged. Turn off the ignition and set the blower head evenly on the ground. Put the loader in neutral and set the parking brake. Once outside, turn off the radio remote control switch, then wait for the red light before turning off the battery disconnect. Spend a few minutes looking over the blower head, taking note of any additional wear or damage. Clean the blower head, removing any icy, built-up material. If additional shear bolts were used, resupply them, adding them back into the tool bag. Finally, write up any problem areas that may require attention so that it can be passed on to the next shift. In closing, it's important that when we disembark, we leave the machine in a positive state for the next operator. If you have any additional knowledge or advice regarding this machine, please share it amongst your coworkers.